Okay, hello to everybody who will watch this. Today we will continue our material about electrical circuits on DC mode, on direct current, and mathematical approaches that we have to deal with it. Today, I think we or finish everything or almost finish, almost will finish everything, because we should look on the such-called superposition theorem and should look on the Thevenin theorem or equivalent generator method, the other name of the same thing. And the next material will be on sinusoidal current. As we discussed previously, on direct current, we have a couple of approaches. For simple circles, it is finding the total resistance of the whole circle. And we have a couple of methods to simplify the resistances. Serial connection, parallel connection, and Y-delta connection, or such-called star triangle connection. Also for complex circles, we have a couple of methods based on Kirchhoff's law or direct application of this laws, or we could transform this method into a couple of more simple for number of mathematical equation, for number of metrics that we will solve on the computer for calculation. It was a transformation of the same laws that we called mesh method and node method, mesh currents and node voltages. And today, the last two methods that we could also use, if we want to find all currents, all voltages, all powers in system, everything, then more useful will be the first two, node method and mesh current method. But for some specific cases, more useful will be superposition and equivalent generator, and the situation like this. Superposition, the idea is very simple. For the linear circles, it is the most important thing that this method, it could be used only for linear circles. Mm-hmm. It is mean that we know all resistances. At the beginning of our course, we were discussing that if our resistance is constant, just a number, then it's called linear. If our resistances are function of any other parameter. Function from any parameter, for example, temperature or current or voltage or any other thing, any function. That is called nonlinear. What is the problem? If it is nonlinear, if it is function, we don't know the resistance. And if we are doing some system of equation, firstly, we have to find the resistances. Generally, if we will return to any method, for example, for mesh current, and we'll take any example, in linear circles, after we found the equations, we know the resistances. We could substitute numbers independently which value of current we will use. If we, for example, increase voltage, we will increase current, but the resistances will stay the same. It is linear. In nonlinear circles, these numbers we already don't know, And if you will look in the equation, it will be with lots of unknown variables. The number of unknown variables will be higher than the number of equations. That is mean that we cannot solve them in direct form, just using linear algebra. And we should use some specific approach, some specific cases, and we will discuss it at the end of the discipline, I think in December. It is sometimes possible, sometimes impossible, but the main difference will be that in these equations, the resistivities will be also unknown variables, unknown functions. But for mesh current and node voltages for first two methods, the application will be the same. Okay, we will have problem to find the resistivities, but in general, we could make this equation. We could write them, and they will be valid. But for superposition method, the main difference that for non-linear circles, we cannot even write the correct equations, because the application of this method in direct form will be incorrect, because the idea is to divide the effects of different sources of energy. For example, if you have two sources, for example, electromotive force 1, electromotive force 2, and they are acting simultaneously, then they are acting on some resistors, and we could divide this effect into different tasks. We could solve task with only one source as a partial effect, and we could calculate task with second source also as a partial effect. For example, if total currents from these two sources 4 amperes, then, for example, we could calculate current from the one source. For example, it could be 2.5 amperes, and we could find current from the independent second source if it acting only as one source, and find current influence, for example, 1.5 from the second source, and we could add them and obtain the initial 4 amperes from the both of them. That is mean that they are acting independently, and we could divide their actions into different tasks. We will have system of equation this here, system of equation here, and we will solve this system independently. But it is valid if our resistance is a number, is a constant. But if it, for example, function, from any, maybe from time, but it could be from current or from temperature, from any other parameter, for example, from current. Then the value of resistivity in total task could differ from the value of resistivity in partial tasks. For example, if resistivity determined by current, and in partial tasks the current will be different will be smaller than the total one, because we are looking on the each source independently. Then the resistivity will be differ from the initial task, and the solution that we obtain after adding will be incorrect. It is the main problem. Generally, we could find resistivity from the initial task and substitute this resistivity into each partial task. It will be some mathematical some mathematical approach, some mathematical interesting thing to deal with this problem. But it will be not solving task into a direct way. It will be some assumption that we should primarily found, and it is not so easy as it looks like. That is why in general, because the resistivity will be different, and because we cannot find resistivity at the beginning of the task to substitute later, then we are speaking that for non-linear case, we cannot use the superposition method. Just because of it. We could look at this idea just for very simple task. For example, some circle. Let it be circle with the same resistivities, for example, by 10 ohms. And task with the same sources, for example, I don't know, let it be 10 volts. In linear case, if it is constant, everything is quite simple. The idea of the method that we are calculating each part of the task, we have part number 1, part number 2. In part number 1, we are disconnecting the source, substituting by a conductor. Then in this case, two resistivities will be 10 in parallel to 10. It will be 5 ohms. The total resistivity will be 15 ohms, 10 plus 5. And the total current will be 10 over 15. And for example, if we are searching for the current in central branch, the current in the central branch will be twice smaller than the total one. The total will be here, and it will divide on two equivalent parts into the same parts. It will be 10 over 30 in amperes. Then the same if we are doing the same steps for the second source, independently. It will be also affecting on the 15 ohms resistivity. The partial current from the first source will be the same, 10 over 15, and the current in central branch will be also 10 over 30 amperes. And the total current from two sources will be the superposition of both these currents. Oh, sorry. Will be the superposition of both these current, and the total current will be 20 over 30 amperes. And as you see, we solve this task without any mesh current, without any node voltages, because if we have two sources in the previous methods, we should use or mesh currents or node voltages methods to find the potentials of some nodes. And it will be some system of equation with solution. But here, without any system, just using the total resistivity of the system, we find the total current from both sources. And everything is okay. But if we will have some function of resistivity, if we will have resistivity non-linear, it is pointed like this, with such pointed, and it, for example, could be some function of current. For example, 10 plus some parameter and current value, some function from current. Then for different currents, it will be different value. For the total task, when both of sources acting, it will be one value, but from partial acting of each source, it will be completely different value because the current is different. And the total solution will be incorrect because the value will change. It also could be seen on the voltage ampere graph. For linear case, the dependence is straight line, and in any point for any current, the angle that equals resistivity, because the tangent function of the angle equals voltage over current, and it equals resistivity. It will be the same for each point, for each value of current. But for curve, for non-linear resistivity, and you could imagine the value of the angle and the value of resistivity will be completely different. And for 3 current points, it will be different value. That is why I pay so much attention for non-linear case and telling that superposition method could be applied for non-linear case. Only linear case, and cannot be applied for non-linear. Why it is useful? Because for now, I will show the idea or on the simple task, and not exactly in the way that is used on the practice. Because for now, we will discuss it that if we have couple of sources of energy, we could calculate it independently. Yeah, it is completely true. It is completely okay. But the main application of superposition method will be for some dealing with complex signal. For example, it is very useful if we are dealing with different sources, maybe combination of direct and alternating sources in one circle, and we could divide them into different calculations, because direct current source we are calculating just in numbers, just in general algebra, but alternating current, sinusoidal function, on the next lecture you will see that we are dealing with complex number. We are dealing with some complex vector, and it will be not just a number, but some real part and imaginary part, some vector form. Why it is so, I will tell. I will try to explain, but just for now, we see that it will be completely different calculations. It is first main application if we have different sources. And the second main application, if we are dealing with some complex form of signal, for example, with some disturbances, with some external effects. For example, it could be non-sinusoidal signal. Generally, we discuss then that in our networks, we have ideal sinusoid, but it is not so. From the alternative sources of energy, all solar power, wind power, all high non-linear loads, as for example, industrial loads, some industrial equipment, it makes lots of disturbances, and the real form of signal, it depends from sinusoid. It could be something like that. It could be something like that. Or so on and so on. It could be any form that generally similar to sinusoid, but not exactly sinusoid. And the main question, how to deal with it. And the idea will be, if we have some complex function with not sinusoidal form, we could represent it in the Fourier row as a number of ideal sinusoid functions. It will be some row of sinusoidal functions with different frequencies. And using the Fourier transform, it will be a combination of ideal sinusoid with different frequencies, and it will be such sequence. And so on and so on. And this application is grounded on the superposition method. Everything that some hard task for us, we want to represent as combination of more simple tasks, it will be superposition method. For example, also in three-phase network, if we have such called non-symmetrical case, it is more connected with electrical networks, not with general electrical engineering, but more practical case for distribution of energy. That is why we don't deal with it inside our course, but for specialties more closely for electrical production and electrical consumption education. These student specialties deal with such called three-phase networks. And in this case, it will be three different sources. It gives us symmetrical picture in vector form of the voltages in sinusoidal. Each of these source gives us sinusoid. We transform it in complex form that I will tell next time. And we represent it as a vector. And each sinusoid moved on the 120 degrees compared with the previous one. And as a result, we will obtain the symmetrical case of vectors. But for tasks that we have non-symmetrical case, some not symmetrical case, for example, something like this, we could represent it a superposition of 3 symmetrical individual tasks. It is also will use superposition method. For example, sum 3 symmetrical cases that in total will give us initial not symmetrical case. Then just lots of application. It is a very useful method in engineering practice, but the main idea, something complex, represent as adding of some simple tasks. And for example, 3, 4, 5 simple tasks in general will be much easier to deal with than calculate the initial one. Okay, it is the main overview. For now, for our case, it will be superposition of direct sources. It is mean that superposition theorem tells us about superposition principle, and it tells us that each source affect separately. Then we could, instead of one task, for example, here with 2 sources, represent 2 different tasks which with influence of each source. And each source we are disconnecting from the circle, we are switching off its power. For voltage source, E, in ideal case, the internal resistance should be very small. It is closely to 0. That is why when we are switching this source off, it became as a conductor. Just as a conductor. But for current source, internal resistivity in ideal case is close to infinity. Voltage source and current source, it is 2 opposite cases of mathematical model. It is completely opposite case of the source, and if we are switching it off, we are dealing with very high resistance. And it is mean that after switching off, it becomes open circle, just as a open branch. It is specification of applying these sources. Here it is. And the idea, as I told, for current, it became couple of currents from each source separately. Each voltage could be a sum of different voltages from each source separately. How many sources do you have? Such many parts in the equation you will get. Such many partial current or partial voltage you will have. For example, for 2 sources, you will have 2 different parts, 2 different partial currents and voltages. If, for example, it will be 5 sources, then you will have 5 partial tasks. For 10 sources, you will have 10 partial tasks, and so on and so on. And also one restriction that you cannot do the same for power. For power, it doesn't work. You cannot obtain power from each source separately, add them, and obtain the total one. Because superposition method is valid for linear functions. Not only resistivity should be linear, but this method could be applied for only linear functions. Current and voltage, they are linear because they are connected using a constant r. But for power is a quadratic function. Power it is joule heating, or square of current, or square of voltage, divide on resistivity. In any case, if you are dealing with quadratic function, for our example, it is current. You cannot use superposition method, and it will not be total current on the resistivity. You could see it here. For example, how we could check it. You have some total current, then in superposition form equals to partial currents from each source. Total power, total joule heating from this current equals I square R. If you are substituting total current as two partial sum of two partial, you will obtain this equation. The total power equals this. But if you are finding partial powers from each current and adding them, you are just obtain equation like this. And as you see, adding of squares not equal to square of adding. And that is why for power it doesn't work. For power, you should find total current firstly, and then using this total current, obtain total power of your task in the initial circle. It is just second restriction for this method. It is very important not to forget about it. In all other things, everything is quite simple. You are dividing current and voltages into parts. For example, on this task, it is quite easy to see. We have two sources, 10 volt and 1 ampere of current source, two resistivities, 5 ohm and 10 ohms. Then let's divide this task onto the two parts, and then we'll add them after the solution. In the first part, we are substituting current source as the open circle. In the second part, we are substituting voltage source as a wire, connecting wire as zero resistance. Then algorithm is like here. The first step, pointing the direction of currents that we want to find. Second step, separate into different circles. In each circle should be only one partial source. For example, if we have 5 sources here, we will have 5 partial circles. In each of them, only one source is present. And then we are pointing the direction of partial currents, solving them using some method, for example, total resistance. And after it, comparing the direction of partial currents with the direction of real currents, of total current, we will add them to obtain the final solution. For example, in first, let's make a couple of pictures. To see the circles all the time. Here they are. Here they are. In the first case, we are finding partial currents from the electromotive force. In third branch, current will be 0 because of open circle. In the two central branches, in left and central branch, current will be equal and equals electromotive force divided on two resistances. Because in this situation, because of absence current, we will have only one mesh for current flow, and resistances will be serial. Then find each of current here, indicates each voltage from this current. Voltage on the first resistor will be about 7 volt, voltage on the second resistor will be about 3 volts. In total, it will be 10 volts from the source. We see that solution is valid because we check the Kirchhoff law after the solution in this mesh. The second circle, the same idea. In this case, the total current from the source. In third branch, current will equals the source 1 ampere. It will divide on two parts proportionally to the value of resistance. It is 1 ampere in total, and resistor ratio equals 10 to 5 or 2 to 1. Then current will divide as 1 to 2. In the bigger resistance, smaller current will flow. In the smaller resistance, bigger current will flow. If we have 1 ampere in total, then 0.3 will flow here, and 0.7 will flow here. 7 over 3 will be almost 2. 10 over 5 equals 2. Just a reversed ratio of the current flow. And it is here. Yeah, it is here. You are adding current and voltages, and the same you are in the second circles after finding current, multiplying the resistivity and find voltage. Each voltage equals about 3 volt. It is mean that voltage on the source of current also 3 volts. Because we have 3 parallel branches, 1, 2, 3, they are parallel, and the voltage will be the same 3 volt on each of these branches. Then at the end, depending from the direction, you are adding currents, comparing with the total one. As you see, direction of total currents, you see the direction of partial currents. In the central branch, they are the same. Central branch arrow looks down. Then it is here. Sorry, not central, it is number 2. It is here. You are just adding them. Then in left branch, left direction equals, right direction is opposite. That is why right direction with minus. And in right branch, you have only one current, the second equals 0. You are taking this current with plus because the direction the same. That is how you are pointing the sign plus or minus. The same for voltages. On the first resistor, depending on the current direction, because current direction left positive and right is negative, comparing with the initial direction, then you are taking the same as it was here, current difference, it will be the same voltage difference for resistor and the total voltage here. In the central branch, you are adding currents. That is why you are adding voltages. And the answer is here. For example, if you will calculate this circle using some mesh current method, you will obtain these values as you find from the superposition theorem. You will get the same value. We could check it quite quickly, because if we will solve it with mesh current, then mesh current here will be 1 ampere. Mesh current here, it will be unknown variable. For example, I11. You should multiply on both of resistivities, add this mesh current J, and equalize to electromotive force. It will be your equation for solution with mesh current. Then this unknown variable multiplying on 10 plus 5 on 15 plus 1 ampere will be the value of electromotive force, will be 10. Then it means that it will be 9, and current, mesh current, will be 9 over 15, or it will be 3 over 5. 3 over 5, it will be 0.6. Yeah? Yeah. 0.67. Then, in the left branch, I1, yeah, if I am calculate everything correctly, yeah, I1, I2, I3. I3 will equals J, and it will be 1 ampere. I2 will equals something I missed. Just let's see what I missed. Oh, sorry, I missed here resistivity. I'm looking that something is wrong. Resistivity is 5, it will be 5 here. Yeah, sorry. Try to do everything faster and making simple mistakes. Because according to dimension, everything will be in volts. Here will be 5, 1 over 5. Here will be 10. The difference will be 5. Then it will be 5 over 15 and 1 over 3, or 0.33. 0.33. Then current in the first branch equals this number, 0.33, and I2 will equals adding of two currents. It will be 1.33. If you are comparing this value, we obtain exactly the same. 0.33 here, 1.33 here, and 1 amperes here. Two methods gives us exactly the same values, exactly the same situations. Just like that. Any question? If everything is okay.
It's okay.
Okay, everything is simple, everything is understandable. Yeah.
Yeah.
Okay, perfect. Also, on the situation of this task, the superposition method is very useful to search for some specific circle mode. If you want to make some setting of the working mode. For example, in this situation, you obtain both currents, some working mode, and you see the central branch I2 equals 1.33 and for two sources that are acting 10 volts and 1 ampere. But let's imagine that you have task, you want to increase voltage to increase current, and increase current for some specific number. For example, you want to increase current to the value 2 amperes, and you are asking what value of the source I should connect for the same current. For the same current source 1 ampere, what electromotive force should I connect to increase the current to the value 2 amperes? In general, you could try to write mesh current equations. In this mesh current equation, substitute current value I2 as already known value. Electromotive will be unknown value. And you also could find some solution in matrix form from this equation. Instead of unknown current will be unknown electromotive force. But it will be more hard way of dealing because you should solve completely all tasks. You should solve completely whole matrix for all currents. If your circle will be with big number of elements, it will be not so easy, not so pretty to deal with. Let's say like that. But what you could do? You could start from the previous mesh, from the previous superposition calculation and say that your current 1.33, it is a combination of two currents, combination from the current of the first task and combination of the current from the second task. In the first task, when only electromotive force acting, here, this current partial, it was electromotive over two resistances. And these two resistances equals 10 plus 5 equals 15. It was partial current from the first task and from the second task, from the current source, from the second part. This current value equals 0.67, yes? The total one. 0.67, it was the total current. Where it is, sorry, just one moment. Here it should be. The total current J 1 ampere, and it divides on two branch. The smaller branch will be 0.67. That it is mean that this second current 0.67. The same value. If your source, second source, stays the same, then partial current from this source stays the same. If you want to change electromotive force to obtain the value of 2 amperes, then you could easily find it from only one equation. You could substitute 2 amperes and electromotive as unknown value into the superposition method and obtain that for this purpose, your E over 15 should equals 2 minus 0.67. It will be 1.33. Multiply on the 15. And it will be 20. If I'm not mistaken, yeah, it should be 20 volts. Then the answer is, if you want to increase current on 2 amperes from the initial case and change only electromotive force, you should substitute. You should increase the electromotive force twicely into the 20 volts, and your current will increase till the value of 2 amperes. It is the second application of superposition theorem, not only for calculating the concrete working mode as you have now, but to find some settings for further working modes, to set working modes for your exactly purpose, for exactly those numbers that you want. To find the value of sources or to find the value of resistivities, how they should be changed to obtain the necessary number of unknown variables. It is the second application. For the second application, is everything okay? Is it clear?
Yeah, it's clear.
Okay, perfect. Then generally the superposition method looks very simple, but it has lots of useful application in further part of disciplines. Caution about using that I discussed about nonlinear functions. For power, we use quadratic function and we cannot use superposition method. We could find total current and after it, only then total power. Works with only linear circles. That is, I already told. And the last one, what we have here, about polarity. Okay, then you should accurate take plus or minus, dependently which comparison of initial current, initial voltages with the partial current and partial voltages you have. Generally, about the superposition method, I think that's all, because there is nothing else to speak about. A couple of practical examples how to deal with it. The second example with 2 electromotive force. The idea is the same. You are disconnecting second source and calculating partial task from the first source using the total resistance, summarizing resistivities in serial, then in parallel to number 3, and all together in serial. And the same for second part, disconnecting the first source, making the same manipulations with resistances, and after all, finding partial voltages, partial currents. For example, in this task, we are asking which power, to find power on the resistor number 3. To find power, we have to find or voltage or current, independently what we more convenient with. In this example, we are finding voltage. Okay, no problem. If we know voltage, we could find power. Also, if we know current, we also could find power. If we are searching for voltage, then in partial case number 1, we find this voltage, 12.5. In partial case number 2, we also find this voltage. It is also 12.5, just because of initial data, which is quite close between resistances. And after it, total voltage equals 25 volts. And because of it, total power could be found as U square over R. In this task, was searching for voltage only to see the second way, because it could be found as square of current on the resistivity. But for current, we did previously, and it would be the same task. Just for some differences, for some different approach, we are starting from voltage, just as second way to find the same value. U square over R, also Joule heating, equals 31 volts of power. And that's all. That's all for the superposition method. Then couple of useful ideas to simplify of the circle, just to revise what we were speaking previously, that sources could be combined in the total one if they are adding in serial. The current sources could be also summarized in the total one if they connected in parallel. All resistivities could be transformed in the whole one, and that after we disconnecting sources, we obtain short circle for electromotive and open circle for current source. And also each electromotive could be substituted by current source. Each current source could be substituted by electromotive source. All this idea we will need for the next, the last method for direct current, that is called equivalent generator. The idea is also quite interesting. If you have some circle, let's see it on some practical case. For example, here. What is the idea of equivalent generator method? If you have some circle and interested in some part of this circle, for example, you don't interested in all of consumers, you are interested in some specific branch. Some specific branch of your engineering interest. And you want to find lots of values, lots of variants of this working mode. What will be if this resistor will be 18? What will be if this resistor will be 10? What will be resistance? For example, you want to find the dependence of different working modes in this branch. What will be if you change the value of resistivities in lots of ways? Substituting different consumers. In this task, if you will substitute 5 different consumers, you should solve 5 different tasks. For example, mesh current, you have matrix 3 rows, 3 columns. You have solved 3 matrices for all currents 5 times. But you don't need all currents. Generally, you are interested only in one branch. Why you have to find 6 currents 5 times? You are interested in only one current. For this purpose, you could substitute all the rest of the circle as some equivalent simple model. For example, okay, you have some block with 2 points of connection, A and C. It is called 2 nodes or a port, just maybe 2 nodes system, because you have 2 points of connection, A, C, something inside it, some element inside this box, and you even not so interested in what inside it, but you're adding different resistances as your load R3 and moving through all 5 variants. Then, if you can represent this complex object as a simple one, it will be quite easier. And the Thevenin theorem inside this method, Thevenin theorem, it tells us that any circle with 2 points of connection, it calls active 2 poles because you have 2 poles, and inside it you have source of energy. If you don't have source of energy, it called passive. If you have source, it called active. Active 2 poles. And any object like this, you could substitute into the source and resistor some equivalent electromotive force and some equivalent resistivities. The main question, what will be the value? How to find them? They could be found using the equivalent generator method, using some mathematical manipulations. But then, after you substitute resistivity, you could find current, power, and voltage into just one formula, dividing your equivalent electromotive force over 2 resistance. And it will be quite easier, because instead of calculating matrix 3 on 3, system of equation 5 times, you could only substitute 5 numbers in one formula and obtain 5 numbers without any system. It is quite easier. And just imagine, okay, here is only 3 meshes. But for example, if you have a big system, for example, with 1,000 meshes, you have to find solution of matrix 1,000 on the 1,000 on the dimension. And for example, you want to search for 100 different values of resistivities. You have to solve this dimension of matrix 1,000 times. Instead of it, you could use only one formula, also 1,000 times. It will be much easier for computer, for quicker calculation, and it is the main idea why we are interested in this method. Is it okay if this idea understandable?
Yeah.
Okay, perfect. Then just the main question, how to find this substitution. How to find equivalent generator if we have initial circle? Let's see. Let's also say a couple words about this transformation, because I'm not sure if we speak it previously. Also, any electromotive force could be substituted by current source using this formula. For example, if you have electromotive force 10 volts with internal resistance 10 ohm, and you want to connection to some load, for example, 50 ohm, you will get current I in this load, in this consumer, as 10 over 60. 10 over 60, it will be current in this circle. You could substitute this source into current J, divide your electromotive into internal resistance. It will be 10 over 10. It means 1 ampere. And internal resistance 10, the same value in parallel, and connect your load to this source of current. Any source of voltage you could substitute as source of current using this formula. And the opposite transformation. Any source of current you could substitute by electromotive force, and the value of electromotive force will be J multiplied on R0. Just reversed formula. And let's check that the current will be the same. This 1 amperes will divide into 2 branches dependently on the value of resistivities. Here will be 1 over, it should be multiply on the 10 and divide on the sum of resistivities on 10 plus 50. In this branch will be current 1 on 50 and divide on 60. 1 over 6 and 5 over 6 in total will be 1. And as you see, you obtain the same current. Current in the load here 1 over 6, and current in the load here also 1 over 6. That is mean that this transformation is valid and everything could be done. Just one other type of transformation. Then, what about this theorem? It tells us that any object only with resistances could be transformed as the total one. We already discussed it previously, that for any combination of resistivities, you could find the equivalent resistivity in total. Here we say that active object with source inside also could be represented or as electromotive force with resistivity or current source with resistivity, dependent which situation is more useful for you, which situation is better for you for making your engineering calculation. You could take any of B or C case. And the theorem tells us that it could be done for any object, any electrical network with 2 terminals or 2 points could be transformed into this way, into Thevenin source. That is why it is called Thevenin theorem. This type of connection, it is called Thevenin, just by the name of the scientist. And this type of connection is called Norton, also by the name of scientist. And if you are taking Thevenin type of connection, a type of generator. The method to find this unknown circle, to find these two values, it is next. First of all, let's check it on some test. Find the equivalent generator, for this circle. Let's find equivalent generator to substitute it with. To substitute with electromotive force and internal resistance. How it could be done? The electromotive force, let's make photo to see it near the eyes every time. Here it is. To substitute this initial circle with 9 volts electromotive, 6 milliamperes current source, 3 kilo ohms and 1.5 kilo ohms of resistivities, instead to substitute by Thevenin type of generator. What should we do? Firstly, we should find the voltage between points between which we want to find this equivalent generator between points A and B in any way. We could use mesh current, we could use node voltages, just our goal to find this voltage. Because here is 3 parallel branches, it's more useful to use node voltage method because we are interested in voltages and because branches are parallel. But in any case, we could use mesh currents and also starting from currents, find this voltage. If we are using node voltage method, it will be voltage method of 2 nodes because point B equals 0, point A we are looking for. And voltage between them will be electromotive over resistivity plus current in upper part and divide on conductivities, conductivities of each branch, and the branch with current source conductivity equals 0. That is why we have only conductivities with resistors. And as a result, after substituting all values, we obtain that voltage between these 2 points, A and B, equals to 12 volts. It is mean that value of source equals 12 volts. Then how to find resistivity? It could be found after disconnecting the sources, like here. You are disconnecting the sources, then your electromotive became connecting wire, your current source became open circle, like here, and total resistivity, 2 parallel resistance between points A and B, 1 kilo. It is the first way how to find this resistivity. 1 kilo. That's all. That's all. Then, if you take initial source and connect some consumer, and if you will take this equivalent generator and connect the same consumer, the currents in both cases will be exactly equal. It is the result of application of the equivalent generator method. It is the first way how it could be found if you have equivalent circle. If you have drawing picture with all values, with all type of connections. If you have equipment and you should find this value experimentally, it could differ a little bit, and we will speak it just now. For theoretical calculation, it looks like this. Any questions? Is everything okay with it?
It's okay.
Okay, perfect. Then how it could be found experimentally? If you don't have the circle like this, you have some unknown circle black box and want to find what inside it in the simplest form. Then you are taking two experiments. You are measuring voltage in open circle mode, just adding voltmeter here. And the value of electromotive force will be the measurement of voltmeter. Then you are connecting this source in short circle mode, just as zero resistance wire, and measuring current inside it using ampere meter inside, obtaining some current. And this resistivity, it equals values of voltmeter in open circle mode and measurement of ampere meter in short circle mode. And that is how you could experimentally find both of these values. Why is it so? Because for any electromotive with internal resistance, you have a voltage ampere line, voltage ampere characteristic. For the ideal source, if you don't have resistivity, the characteristic will be straight line equals electromotive force. For a real source with resistor, this straight line will be with some angle, and it differs from the ideal case. It looks like this. Because in this case, the voltage between points A and B, if you are closing this circle by some resistance, the voltage between points A and B, or points 1 and 2, it equals electromotive force of the generator minus drop on the internal resistance, minus current over the resistivity. As bigger current is, as bigger the drop is, and the total voltage will decrease on the points 1 and 2. If you will get the highest possible current, and the highest possible current will be by the smallest resistance. And the smallest resistance is a short circle mode, just a zero wire. Then if the current is maximum, then it equals electromotive, and their difference equals zero. You have short circle point. The biggest point, it is open circle. The smallest point of voltage is a short circle. And the resistivity, internal resistivity, it is an angle of this curve. It is a tangent function of this angle equals resistivity. That is why if you are inside the experiment, point number 1, taking open circle mode, point number 2, taking short circle mode, then you could build this straight line, you could find the angle, voltage, it is one part of triangle. Current is the second part of triangle. Voltage over current, it is a tangent function. That is why you're obtaining resistance. It is the second way. If you don't have a view of the circle, but you have experimental equipment, you could measure two values and find the Thevenin's equivalent circle. If you have equivalent circle, you could find it theoretically just by calculation. Just one moment. Cat is very hungry.
Okay.
Sorry, just very, very hungry cat.
Okay, it's nothing. No problem.
Okay. Okay. Then we almost finish with all these calculations. Experimental discussed, theoretical discussed. What we also have here, the algorithm that takes us how to deal with it, finding open circle voltage, it equals electromotive, finding resistivities, or experimentally or theoretical from the circle, and after it, find current on the load, after connection this load, from one formula, from one source, or from in the initial case, it will be exactly the same as in simple model, as we found 12 volts, 1 kilo ohm Thevenin equivalent circle. Also, this method is quite useful when we want to measure lots of variants of working mode. For example, if this resistance became variable, as I speak at the beginning, we are substituting lots of different numbers of the load and discussing what change will be in our circle, how voltage, current, and power on this resistor, on this cherry resistor, will difference from the value of resistivity. 1 ohm, 10 ohm, 100 ohm, 1 kilo ohm, 10 kilo ohm, 100 kilo ohm. As a result, voltage increase, current decrease as we increase resistivity, power will have maximum. Why it have maximum, I think we will summarize next time, just not to discuss lots of information simultaneously. Next time we will speak a little bit about power transfer between objects, what graphs and what functions we will have inside this power transfer, what working mode is better, in which case the power will be bigger, in which case coefficient of efficiency in percent will be better. We will discuss that it will be two different okay. We will discuss that it will be two different characteristics and they cannot be the high number of power and high number of efficiency cannot be reached simultaneously. Or we using high power mode, but with less efficiency. Why are you screaming?
Okay, maybe you can feed it.
No problem. My wife feed it, just asking for some attention. Okay, and then just some attention. Okay, what I want, the last point of view, what will be next time? That if we want to reach high power, it will be not with very high efficiency. If we want to reach high efficiency, it will not be with high power. It's two different characteristics. And also we will start from this graph and discuss why it's so. something about transfer. And generally, that will be all. Then we will move to the alternating current to the alternating sinusoidal working modes. Please, if you want, if you have any questions, please welcome. We'll be glad to answer.
Okay, but no question?
Okay, glad to hear it. Then the recording also will be on YouTube, everything as usual, next time as usual. And then just thank you for your attention and see you next time.
Okay, have a nice day. Bye.
Thank you. Same to you. Have a nice day.